Ladies and gentlemen, welcome to my job shop. My name is Keith and I'm your host. Today we have a new job. We're going to be doing, it's kind of simple. We have municipality that came by and asked us to take 1/8 of an inch off of the length of this double flange pipe assembly here. This is 20 inches and about 11 inch in diameter. I don't have any way to really support the end of it because we're going to be working on the face of it. Some jobs are more the setup than they are the actual cut. If we set this up well enough, the cut's going to be pretty simple. And I'll hit a couple other things that I want to talk about as far as the surface finish that we put on the flange and stuff like that. That'll come out later. All right. We're going to run this in the closing. I got to pull off my little protectors here, and we're going to spread out the jaws. And a combination of the jaws and toe clamp in it is how we're going to hold it in here. The other option I do have is the 30-inch faceplate back there. I'm probably still going to have to pull my gap out of here and get swing for the chuck jaws that will be sticking out. I say that about 11 inches, we're going to be just inside the toe clamp. So we're going to be using this, but I'm going to show you a little trick that I use here for toe clamping something with a short reach, not having room back here for the step block. And also, these jaws are about 5 inches long, and if they're going to be out past here, they're going to be here. So we are going to have interference on the bed here itself. All right, let's move on in. Got all of our bolts loose on our gap. Our gap's loose. Whenever I install it, I do float it on a coat of oil so it's always nice and slick and slides in here. I have a lot of people go, oh, I'm afraid to pull my gap in my lathe. Well, if you're not ever going to pull your gap out, why'd you buy a gap lathe? Just treat the mating surfaces to the face and to the base like your ways. Don't mistreat them. And you'll have repeatable capabilities. Now this lathe is, well, it's as old as I am, so it's pretty beat. But it still gets the job done. Let's go ahead and open up the jaws here so that we can get our diameter clearance for a face contact with the flange on one side here. And I'm going to say that that is probably going to be a good starting point. This face here to the outside here. It'll probably be a little bit larger, but we'll know as soon as I set this one here. Okay, and okay, we got 11 1/4, and our flange is 11 right on the money. So it looks like we got enough clearance to put this in against the face to start. Okay, now we're gonna roll our part over. We already have it on the gantry here, and there we go. Pretty flat against there right now. That looks good. All right, I'm just gonna put my chain up here for right now, and we're in all neutrals. I like roughing things in using the lines on the chuck here, and it kind of helps you get it a quick reference there. Okay, we're going to add just a little bit to the up here. There we go. All right, I'm kind of just double checking. I don't want to squeeze directly in over one of these openings. Not that that shouldn't handle the pressure in there, but it's not really ideal. Just one of those things you kind of look at. All right, now I know all the chuck jaws are going to be in on a good solid part of the flange here. Okay. All right. Now, this is not normal practice, but because of my carpal tunnel and not stressing out on my wrist right now, I am using my aluminum bar, and I am using a little bit of compensation is basically all I'm going to call that. Okay. We can come down off of our hoist now. And for right now, I'm just putting a little bit of added protection right here. Just in case this comes down, I don't need to whack it right there on the steady rest sliding area there. Okay. And that's not too bad. Just for kicks, let me see here. Probably like right here is probably going to be a good visual for you. We'll just see how close we are right here. Okay, now this is not the most important measurement right there, but I'm probably within 50,000. Actually, probably even closer than 50 thousandths. Actually, now, of course, I have to, right? I have to. Just because, let me see here. For you guys that need 0, 50, it went up to 60, and it went down to 50. It's just one little dip there. So, yeah, 100 thousandths total run out, so we're within 50 thousandths right there. Okay, so much for eyeball close. Let's get this toe clamp down to the chuck. I'm going to grab the hardware that I want to fit on here, and I'm going to show you how I compensate for having such a short throw right there. I got a couple of 3 ways to show you a toe clamping situation right here. This distance right here ended up not being extreme. These T-nuts in this chuck here, and actually I want to set it up and actually go in with my 1/2-inch cutter and redress these T-slots, because I would like them to fit my regular 1/2-inch T-slots. I can run my 7/16 and my 3/8. So with that said, one way, if you're having to toe clamp this part here, you end up being off the edge here. And that's what this one situation right here would be, to go ahead and put the T-nut in there, and then take one of your toe clamps that you've modified with another draw thread here or enough footprint. It doesn't matter. It comes in a couple different areas. So you could use this as a push or this as a flat platform. And in this case would be to use the extra long stud to go ahead and hold your toe clamp here, and then your support out here. You probably wouldn't need a tall one like that, but you could probably get by with a short one like this. And then you would be able to toe clamp that down with this stud being just a little bit longer. I'm using this as a situation to show you that you can extend something out past. I mean, you have your jaws sticking out that far. It's not going to interfere on the swing. All you're trying to do is get the hold down pressure on there. Okay, so that was one way. Now let me show you two ways that I'm actually using. First off, we get our T-nut in here, and this is our toe clamp down. Now this toe clamp is pretty close here. It's a good comfortable fit in here, and we got enough draw on the nut. We're looking good there. Now this is the foot that I want back here, but the pressure is kind of iffy on the clamp here, spreading between, lining up with the groove here so we have enough support underneath here. The block overhanging the back side here. All right, let me show you how I remedy that. I take a block, substantial thickness here, so that I can get this block supported, and you can let this overhang the outside. What's the difference here? Let me tighten this down so I can actually show you. Okay, now this surface here definitely is way above this. But if you take and straight line your pressure point down, you have basically 5/16 or 3/8 there pushing forward on this block. So your contact of your block now is from here to here. And then this extends out past, and that kind of gives you a buffer point. So you're clamping between here and here with your block by putting this other block in here, because you're holding the front edge of this block down that direction as well as you are this block in this direction here. And that'll compensate your pressure. You're spreading the T-nut wide, so now you're not worried about this lining up or falling in one way or the other on your T-nut slot. And this could be any thickness or whatever to get you the situation you want. This is sticking out, it doesn't matter. All of the stick out is still less than our jaws. Mine is about a 1/2 inch forward, but we're not going to be going there. All right, let me tighten that one up, and we're going to go to the second way. We got two jaws we're holding in with this method, and then we come up with another method, because we didn't have two similar lengths of toe clamps without going all the way up to our 1/2 inch and then really having to draw a stud that wouldn't fit in here. Our 1/2 inch studs won't fit in here in our 7/16. So I create a push-pull. This is a rest, and this is the hold down. And we take the draw nut in here. Wrong one. Okay, this is an upside down nut that goes right into that groove, and we adjust it so that we know we got the right pressure both sides equally. Now we can put a nut on here with a washer and draw that down. As soon as I find that, oh, my 3/8 nuts are up here. We have another nut for that. With this nut here, we don't need this washer. We double nutted this so that we could screw it in. Our toe clamps now are in position. So now we can finalize and check how our face is running out. Let's see. Let's see where we're at right here. That looks pretty good. All right. See if I can put an indicator on here now. Let's see what we got here. Can you see that? Let me move you. Okay, I'm not gonna bother putting it on 0. Couple little beep, but other than that, the thing is less than 50 thousandths. All right, I think I'm gonna tighten it down, and I'm gonna tighten it down, and then we'll come back. We'll measure the face, and then we're gonna start facing off the material we need to take off. Just kind of snug these down. Okay. All right, I'd say she's pretty secure right now. Okay, this is iron, so I'm probably not going to be throwing iron dust all over here. I'm going to cover the ways and everything else. But let's go ahead and put an indicator here now, and just for curiosity, we're going to see how close face to face is. And they're just asking us to go ahead and take 1/8 of an inch off of here. And I'm not going to touch the dial. Okay, the face is running within 10 thousandths. That's pretty good for something this crude. If you look real close, you'll see the lines going like this. In fact, actually, probably if I take a wire brush, I don't have a wire brush, but maybe. Yeah, see that? Yeah, okay. And actually, you can probably hear it here too as well. Okay, there's a lot of crud in there, but you see each one of these grooves here. That surface right there is called a phonographic finish, like a record player, and that's how it got its name. So we're kind of looking at that coarseness of that, and that's put in there so that it gives the face of the rubber gasket a surface to grab a hold of, be able to tighten down and create the seal. So that's what that surface is all about. We're going to try to duplicate that look right there, and just kind of looking at, there's about 4 grooves in 1/8 of an inch. maybe 5 grooves in an 1/8 of an inch. All right, we put one of our scales up here that we can read hundredths here, and we got 19 inches 775 from the face of the chuck. So at least we know that dimension minus an 1/8 of an inch will be our finished dimension. We've got our ways covered in this little area right here so that the material flying is not going to go too far. Another thing that I really like is this. This is called a rook. I got this at the Barsley Summer Bash some time ago. So I can't tell you where to get it anything else. I just know it's called the rook because it does look like a rook or a castle. It's a magnet on this side here, and basically it's just a thumb screw and hold indicators and things like that. But my favorite thing to do is I drill a hole in my paintbrushes here, and so I can use this, stick it right to the tool holder, and bring the bristles of the brush just above the tool cutter so that it disrupts the spray flying in the air and kind of lets things going straight on down. All right, and then you can just tilt it up out of the way whenever you want, and you can come in. All right, we're going to come in and touch off. Our destination is to come in at 19,650. All right. I think we got a happy speed here. All right, let's touch off. Okay. We're going to call that 0. I think we're just going to try it. We're going to try 25,000 coming across here. Right now I'm happy that I'm not getting too much chatter noise. Of course, our feed is still fairly smooth compared to what we're going to be finishing up at. But I want to make sure the length is set before we get crazy about creating our finish. You can actually see the phonographic finish when it's spinning on a close-up like that. All right, that's a nice finish. And you can see the inner part. There's a pipe that goes through, and I think I'm looking in the back over here, and it's kind of like threaded. So this part is actually threaded on here, and then then they do sealing or whatever. So whatever the surface finish is in here, it does flake off just a tiny bit, but they have a pretty good buildup in here. So, all right, we got probably got 2 more passes before we start playing around with our speeds for our phonographic finish. We finished our third pass. This puts us about 75 thousandths we've taken off. I'm going to go ahead and our feed rate is about 4 thousandths per revolution here. And I think we're going to go ahead and we're going to jockey this on down. Let's give 17 thousandths. Let's give that a shot. That would be C and A. Okay, that looks like it's cruising along pretty good. We're just trying it out, so we're just gonna take a 10 thousandths on the depth. It's cruising along pretty good, but I think we might even increase it a little bit more here. We're gonna make a judgment when we stop it and look at it. And we're gonna have to double that. Let's see what we got here. Okay. Here's another 10. Here we go. Looking closer. Okay. That looks pretty darn good. I don't know if I can make it go any coarser than that on the feet. That's 50 thousandths. That's as coarse as my course is right there. All right, we're gonna keep that up. We got 25 thousandths to take off, so a couple cuts here. Okay, this is my last cut across. Well, we are 19650. Pretty cool. All right, I'm just going to take one of my scab files. All right, just so it's not sharp on the edge. You know, another good topic for comments, and actually I want to thank everybody for the amount of comments and the interest in my last video. It actually kind of lets me know that keeping it real and the kind of videos that you like to watch. So another topic is, how much can you stick out? How much weight can you put out in front or hold up with your chuck? When rigidity becomes the issue, is most of the line drawn that you can't cross. This here, I didn't have any chatter, didn't have any problem taking any of this, but I'm rock solid mounted to the chuck here. It wasn't going, it's not going anywhere. The mass of this really, in realm that it looks like a lot out here, is not really any heavier than the mass of all of this. You also have a certain amount of bearings that are supporting an axis, and the load on those bearings aren't even close to reaching their max. Even though these are precision bearings set up in your gearbox holding your chuck out there, they're very similar to the bearing system set up in the rear end of a vehicle, and the torque and everything else that goes along with it. So I still have to back it up by the line drawn would be where your rigidity, where you'd start to have vibration or something like that. But it may not be, because there's so much weight that's hanging out here. It may be tinny, meaning too thin of material and everything else. This is a pretty good mass. And actually, ductile, you can hang it out. It doesn't sing like if it was stainless steel or it was chromoly or something like that. Those tend to sing more than this did. So anyway, all right, I got to get this out of here. All right, until next time, get her done.